We tend to imagine the deep universe as unfinished. Far enough away, we assume things should start to lose shape. Light should scatter into noise. Structure should thin out into something half-formed and difficult to read. And yet, when James Webb looked into some of the most distant galaxy clusters we have ever studied in this way, it did not simply find blur, it found repetition, curved fragments, echoes of the same background galaxy appearing more than once. A kind of order hidden inside distortion, and the deeper you follow that pattern, the stranger it becomes. If you enjoy long-form journeys like this, where the evidence stays real and the perspective keeps widening, subscribe and stay with me. There is a lot here, and it only gets more interesting the longer you look. So with that in mind, let's begin with something simple. Imagine standing in front of an old pane of uneven glass. On the other side is a streetlight, or a face, or the window of a house across the road. You still recognize what you're looking at, but the glass interferes, the shape stretches, a straight line buckles. One point of light becomes a smear, or a doubled reflection, or a broken crescent. If the glass is warped in just the right way, the object behind it can appear in more than one place at once. That is already close to the heart of this, not because space is made of glass, and not because galaxy clusters behave like simple lenses you would hold in your hand, but because there is something deeply intuitive in the experience of seeing shape survive distortion. The thing behind the lens is real. The distortion is real too, and if you're careful enough, the distortion does not hide the truth. It reveals the shape of the thing doing the distorting. This is the first illusion that has to go. When most people see those Webb images filled with arcs and faint reddish smears, the instinct is to treat them as visual spectacle. Beautiful? Yes. Strange? Certainly. But basically decorative, a byproduct of looking into a distant part of the universe. What astronomers see is harsher and more useful than beauty. They see geometry. They see constraints. They see background galaxies whose light has passed through the gravity of a massive foreground cluster and been bent into repeated patterns that should not exist unless a tremendous amount of mass is arranged in a very particular way. That is what makes the word symmetry useful here, even if it has to be handled carefully. These clusters are not perfect snowflakes hanging in space. They are violent, layered systems full of galaxies, hot gas, dark matter, motion, merger history, and gravitational complexity. But against that complexity, Webb has been picking up something unexpectedly legible. It has been finding repeated image structures, strongly lensed arcs, and organized patterns that allow astronomers to reconstruct the hidden mass distribution of cluster interiors with a level of detail that was simply harder to reach before. And that is where the feeling changes. Because now we're no longer just admiring distant light. We are reading invisible architecture. A galaxy cluster is one of the largest gravitational structures in the universe. Not the largest in a poetic sense, but in a brutally physical one. Hundreds or even thousands of galaxies, enormous reservoirs of hot gas, and vast quantities of dark matter all bound together in a common gravitational well. If you could see only the stars, you would miss most of what matters. The luminous galaxies are the visible islands. The real continent is mostly dark. That is another place where human intuition fails. We are used to trusting what shines. In daily life, the thing that emits light usually feels like the thing that defines the scene. A lamp lights a room, a city glows at night, fire draws the eye and takes over the landscape. But in a galaxy cluster, the bright parts are not the whole story. They are more like sparks tracing the outline of a machine far larger than themselves. Most of the mass is not directly visible. It announces itself indirectly by what it does to other light passing through. So when Webb picks up multiple images of the same remote galaxy behind a cluster, that is not a minor technical success. It is the universe giving away part of its hidden structure. Think about what that means for a moment. A distant galaxy, already unimaginably far away, sends its light toward us across billions of years. On the way, that light passes through the gravitational field of a cluster in the foreground. The path bends. In some cases it bends enough that we do not see one clean image of the background object, but several distorted versions of it, stretched into arcs, curved around the cluster core, mirrored across invisible lines in space. The background galaxy becomes a set of celestial echoes, one source, many appearances. If that sounds abstract, it helps to bring it down into ordinary experience. Imagine hearing one voice in a canyon, and then hearing it return from different surfaces, at different delays, from different angles. You never confuse the echoes for separate people. You understand that one event has been multiplied by the structure of the space around it. The echoes are not noise added to reality. They are reality made legible through an obstacle. In much the same way, those repeated galaxies tell astronomers less about the galaxies themselves than about the gravitational landscape they had to cross. And once you understand that, the image stops being passive, it becomes active evidence. Webb is especially powerful here because it is not just looking far. It is looking with enough sensitivity and enough resolution in the infrared to catch faint, redshifted background galaxies that older observations either missed entirely or could not separate cleanly from everything around them. That matters because every new lensed source, every newly identified multiple image system, gives astronomers another clue, another anchor point, another fixed piece in a puzzle that is otherwise almost impossible to see directly. A map begins to emerge, not from touching the terrain, but from watching how everything bends around it. In some of these cluster studies, Webb has helped identify many new multiple image systems in a single field. That is not just a matter of adding more dots to a chart, it means the mass model can tighten. A cluster core that once felt approximate starts to sharpen. Regions where dark matter must be denser become easier to locate. The relationship between visible galaxies and the broader underlying gravitational structure can be tested more precisely. It is the difference between trying to reconstruct a face from 2 shadows and reconstructing it from 20. That is why the discovery has force far beyond image quality. The visual improvement is only the surface layer. Beneath it is a methodological leap. Webb turns faint smears into usable geometry, and usable geometry turns wonder into measurement. What looked, at first glance, like a distant accident of light becomes something else entirely. It becomes evidence that even at these enormous distances, some clusters are not merely present, they are already organized enough, concentrated enough, and gravitationally coherent enough to carve repeating signatures into the background universe behind them. That is the quiet shock, because the farther away we look, the younger the universe becomes. We are not seeing those clusters as they are now. We are seeing them as they were when the light left them, long before Earth, long before humans, long before anything like human language existed to describe what was happening there. And still, in that remote epoch, there are systems massive enough and structured enough to take the light of even more distant galaxies and fold it into elegant distortions that we can decode here, now, from a small rocky world circling an ordinary star. The old intuition says distance should make reality less readable. Webb keeps finding places where the opposite is true. And once that idea settles in, a harder question begins to rise. If some of these distant clusters are already capable of producing such strong, coherent lensing signatures, what does that say about how quickly the universe learned to build? To feel that question properly, we have to resist the habit of flattening all cosmic time into one blur. The early universe sounds like a single condition, as if everything far away belongs to one vague era of youth and incompletion. It does not. Cosmic history has texture. There are long stretches of cooling, gathering, collapsing, colliding, enriching, and reorganizing. Matter does not simply appear and then wait. It falls, it pools, it deepens wells. It builds structure through gravity, slowly by human standards, but sometimes faster than human intuition is willing to grant. And intuition really is the problem here. We carry into cosmology the emotional logic of ordinary construction. A village appears before a city, a child learns balance before strength, a tree begins as a thin stem, not a cathedral of wood. So we imagine that if we go far enough back, everything large should look diffuse and hesitant, not absent, but soft around the edges. More suggestion than commitment. The deep universe, in that picture, should feel like an early draft. Yet these lensed clusters do not present themselves that way. Not entirely. What Webb has been helping reveal is that some of them already possess the concentrated gravitational interiors needed to bend and multiply background light in striking ways. They are not mature in every sense. No serious astronomer would say that, but neither are they merely half awake. They have enough inner structure to leave fingerprints on light from even farther away. That is a very different image of youth. It helps, here, to picture what a cluster actually is in motion rather than in a still frame. Not a neat ball, not a static island, more like a crowded basin in space-time, a place where matter has been falling inward for a very long time, where galaxies orbit, where hot gas churns, where previous collisions leave scars, and where dark matter shapes the larger gravitational landscape without ever lighting up on its own. Seen from far enough away, it can look serene. Up close, or rather in the equations and maps behind the image, it is dynamic and messy. But messiness does not prevent pattern. In fact, pattern is often what survives the mess. That is the second illusion this story dismantles. We tend to treat order and turbulence as opposites. They are not. A hurricane has structure. River currents form coherent lines through chaos. A face reflected in rough water is distorted, but the distortion itself obeys the motion of the surface. In galaxy clusters, too, disorder is not the end of readability. Sometimes it is the very condition that makes the deeper structure visible. The light bends because the mass is there. The arcs appear because gravity has shape. Once astronomers identify a set of repeated images behind a cluster, something remarkable happens. The image stops being only an observation and becomes a reconstruction problem. Which bent arc corresponds to which background galaxy? Which faint red source is actually the same object appearing again somewhere else in the field? How much mass must sit near the core to create those paths? How smooth is the dark matter distribution? How much of the lensing comes from the cluster-scale halo, and how much from the individual galaxies embedded inside it? This is not guesswork in the casual sense. It is closer to forensic geometry. One source becomes multiple clues. Their positions matter. Their shapes matter. Their relative brightness can matter. Their redshifts matter. Put enough of those clues together, and the range of possible mass arrangements begins to narrow. Not to one perfect answer, because nature rarely gives that kind of gift, but to a family of answers constrained tightly enough that the invisible landscape starts to come into focus. There is something profoundly human in that process. We do not see the dark matter directly. We do not stand inside the cluster. We do not touch its core. We infer it. We watch what older light had to do in order to reach us, and from that performance we reconstruct the stage. A lot of the power of Webb lies right there, in increasing the number and clarity of those performances. The telescope was built to work in infrared light, which is essential when you are chasing ancient, redshifted galaxies whose light has been stretched by the expanding universe. But sensitivity alone would not be enough if the image stayed muddy. What matters is the combination, deep reach, and fine enough detail to separate faint background sources from the crowded glow of the cluster field. That combination turns previously uncertain smudges into identifiable systems. It makes pattern recognition less like squinting at fog and more like finally seeing the hinges in a door that had always been there. In one of the early strong lensing studies using Webb, astronomers examined a set of clusters across a range of distances and found many new multiply image systems that had not been clearly established before. In at least one case, the number of newly identified systems was strikingly high. That does not mean the cluster suddenly changed when Webb looked at it. The structure was already there. The difference is that the field became legible enough for us to read more of what gravity had written into the background light. That shift matters because strong lensing is especially sensitive to the inner regions of a cluster, the place where questions of concentration become harder to avoid. If a cluster can produce giant arcs and repeated images, then whatever its full history may be, its core has achieved something significant. It has gathered mass into a configuration dense and coherent enough to impose itself on the light behind it. You can almost think of it as a kind of gravitational handwriting. Broad, curved, unmistakable. And the moment you say concentration, the emotional meaning of the title deepens. Because now unexpected symmetry is no longer just about visual repetition. It is about a deeper surprise, the existence of enough central organization, enough mass packed into the right regions, that the universe at these distances is not simply visible, but geometrically articulate. A young cosmos in this picture is not mute. That becomes even more striking when we bring in a familiar example. The bullet cluster has long been one of the most discussed cluster systems in astronomy, because it offers a dramatic case where the visible matter and the dominant mass distribution can be teased apart through observation. It is not famous because it is pretty. It is famous because it became one of the most vivid demonstrations that the luminous stuff alone does not account for what gravity is doing. Webb's more recent observations of such systems have added depth to the reconstruction, not by rewriting everything we knew, but by supplying more faint background sources and therefore more ways to tighten the lensing analysis. That is an important tone to keep. The strongest science stories are often not explosions of total overthrow. They are sharpenings, tightenings, a fog lifting, not the entire landscape teleporting into a different place. Webb has been doing that repeatedly. It has not made the universe less stable as an object of study. It has made it less forgiving of lazy intuition. And lazy intuition is exactly what begins to fail once the timescale stretches further. Because there is distant, and then there is distant enough that the mind resists holding on to it. A cluster at moderate cosmological distance is already challenging. But when strong lensing shows up in a cluster at a redshift approaching 2, the emotional force changes. We are no longer just dealing with an impressive lens. We are looking at a system from an era when the universe was much younger, and still finding evidence of a core concentrated enough to produce giant arcs and repeated images of background galaxies. That is where the story stops being only about seeing hidden mass, and becomes a story about how fast hidden mass gathered into serious structure. Not instantly, not magically, not in some way that lets us throw out the discipline of cosmology and replace it with headlines, but fast enough, in at least some cases, to force a more careful look at the pace of assembly, fast enough that the simple emotional picture of a blurry young universe starts to feel inadequate, fast enough that order, under extreme distance, begins to look less like a late luxury and more like one of gravity's earliest commitments. If that sounds subtle, it should. The most important discoveries often are. They do not always arrive with a trumpet blast. Sometimes they arrive as a repeated curve of light where there should have been only one galaxy, and they stay quiet until you realize what kind of structure must already exist for that curve to appear at all. One of the easiest mistakes to make in cosmology is to confuse what is bright with what is important. The image seduces us toward the visible galaxies because the eye needs anchors. We look for shape, color, recognizable points. But when a cluster lenses the background universe, the real authority in the scene belongs to mass whether it shines or not. The arcs are obedient to gravity, not to appearance. They curve around the deeper structure. That is why these observations feel so different once you stop treating them as astronomical photography and start treating them as evidence. A beautiful image asks to be admired. A lensing field asks to be solved. The repeated fragments of distant galaxies are not just ornaments hanging around a cluster core. They are instructions. They are telling us that space-time in this region is bent in a way that only a certain distribution of matter can sustain. If you place yourself mentally inside that field, the strangeness becomes more physical. Imagine looking past a city through moving water. Buildings in the distance stretch into ribbons. Windows detach from walls. One tower appears twice, then disappears, then returns as a warped gleam somewhere else. You would not say the city itself had duplicated. You would understand that the medium between you and the city had become the story. That is what a lensing cluster does to the deeper universe behind it. The background galaxies are real, but the foreground gravity takes over the image. And yet the takeover is not random. This is what gives the whole subject its peculiar calm. We are dealing with tremendous forces and immense distances, but the result is not visual chaos, it is patterned distortion. There are places where the light stretches into long arcs near what astronomers call critical lines, regions where the geometry of the lens becomes especially powerful. There are places where one galaxy appears as several separate images, each path bent differently by the same gravitational landscape. If the cluster were only formless weight, the patterns would not come out this way. The lensing itself tells us that the mass has internal order. Even that word order can be misleading if it sounds too clean. A cluster is not a polished sphere. It can contain substructure, asymmetry, merger remnants, galaxies moving through the common halo, and hot gas that does not perfectly follow the dark matter. But a mountain range can be rough and still have a ridgeline. A storm can be violent and still have a coherent eye wall. Coherence is not the same thing as perfection. What Webb has helped show more clearly is that coherence survives in places where many people instinctively expect only roughness. There is a practical reason this matters so much. Strong lensing lets astronomers probe the inner mass profile of a cluster. That is a technical phrase, but the idea is simple enough. It means we can ask how sharply the mass rises toward the center, how concentrated the core is, how the invisible halo and the visible galaxies combine to shape the gravitational terrain. The more multiple images we can identify, and the better we know where those sources really are in depth and position, the more tightly we can test the shape of that terrain. Think of it like walking through a dark building by listening for echoes. If you clap once in a large empty room, you learn something. If you clap again from a different corner, you learn more. If dozens of sounds come back from many surfaces at many angles, the building starts to declare itself. You do not need full illumination to reconstruct the architecture. You need enough disciplined returns. In lensing studies, the arcs and repeated galaxies are those returns. This is why Webb's contribution is not just sharper imagery in a generic sense. Sharper imagery is a pleasant phrase, but it hides the real achievement. The telescope is exposing more of the faint background population behind cluster lenses, including distant red galaxies that are easier to see in infrared. Those additional sources increase the number of usable constraints, and every new constraint makes it harder for the mass model to wander. The hidden structure has less room to hide behind ambiguity. That shift from ambiguity to pressure is where good science becomes emotionally compelling, not because the universe owes us easy answers, but because the evidence starts narrowing reality in front of us. The cluster can no longer be anything at all. Its mass has to be distributed in a way that accounts for what the light actually did. When enough of those constraints accumulate, even the language around a cluster begins to change. We stop saying only that it is massive. Plenty of things in the universe are massive. We start talking about concentration, about central density, about how efficiently matter has pooled toward the core. That sounds drier than it feels. In human terms, it is the difference between a crowd in a field and a crowd pressing into a narrow doorway. The gravitational consequences are not remotely the same. A broad halo may bend light a little. A dense core can seize it, split it, and throw it back into the sky as a set of giant arcs. Now hold that image against the age of the light. When we observe one of these distant clusters, we are not seeing a late, settled universe taking its time. We are seeing a universe still deep in its own construction history. The light-reaching web has been travelling for billions of years. It carries an older cosmos into our present, and inside that older cosmos, at least some clusters have already built central regions strong enough to function as impressive gravitational lenses. That should not be treated like a violation of physics. It is much more interesting than that. It is a demand for precision. How early can such structures assemble? How common are they? How concentrated can they become? What does that imply about the growth of massive halos under the rules we think govern structure formation? These are not decorative questions. They go straight to the tension between human intuition and cosmic process. Because gravity has a patience that humans do not feel from the inside. We live on the timescale of breaths, conversations, decades, at most a century if we are lucky. Even recorded history is a blink against cosmological time. So when we think young, we import a sense of fragility. But gravity does not understand youth in that emotional sense. Give matter a density field, give it time, give it dark matter scaffolding, and gathering begins. Small differences grow. Over-densities pull harder. Regions feed on surrounding regions. Wells deepen, in the right places, under the right conditions. Structure can become formidable long before the human mind is ready to call it mature. That is why a strongly lensing cluster at great distance feels so powerful. It is not only an object, it is a rebuttal to a feeling. It tells us that the early universe is not best imagined as vague. It is better imagined as active, uneven, rapidly differentiating, with some places already far ahead of the average in the business of becoming deep gravitational systems. There is a kind of harsh beauty in that. Not because the cosmos is cruel, but because it is unsentimental. It does not build evenly. It does not wait for our intuitions to catch up. Some regions gather matter earlier. Some structures concentrate more strongly. Some cluster cores become potent lenses while the broader human image of the young universe is still stuck in soft focus. The title begins to evolve again here. What looked like symmetry in the arcs becomes symmetry in a deeper sense. Repeated evidence pointing back to the same hidden fact. Not that the cluster is simple, but that its invisible mass is organized enough to leave consistent signatures in ancient light. The same truth appears more than once because the light appears more than once. And that repetition does something unusual to the feeling of deep time. Usually, the farther back we look, the less personal reality seems. It becomes abstract, statistical, impossible to place in the body. But lensing reverses some of that distance. You can almost feel the mechanism. Light crosses the universe, gravity intercepts it, paths split, images reappear. We sit here and notice the pattern. A process that took billions of years becomes, for a moment, almost tactile. That tactile quality matters because otherwise the science can become too airy. Concentration parameters, mass distributions, reconstruction methods, cluster redshifts. All of it is real, all of it matters, and all of it can lose emotional contact if left hanging as vocabulary. So bring it back to something human. A child looking through the bottom of a glass bottle, a face reflected in rippled water, headlights seen through heat rising from asphalt at night. In each case, the distortion teaches you something about the medium in between. In cluster lensing, the medium is not a material substance. It is curved space-time shaped by mass. But the logic of reading distortion is still one our minds can inhabit. And once we inhabit it, another question opens naturally. If Webb is making these hidden structures more legible across multiple clusters, and if some of the most distant strong lenses appear more concentrated than simpler expectations might suggest, then we're no longer dealing with one pretty anomaly. We are being nudged toward a broader possibility. The universe may have organized some of its largest structures faster, or earlier, or more efficiently in their cores than our casual mental picture ever allowed. That possibility has to be handled with discipline, because this is exactly where good science communication can go bad. The easy version of the story would be to say that one set of Webb observations overturned everything, that cosmology has somehow been broken by a few elegant arcs, that the universe is behaving in defiance of the rules. But reality is almost never that theatrical. Strong results matter most when they force refinement, not when they are turned into slogans. So it is worth slowing down here and being precise in a way that still feels alive. When astronomers discuss a cluster appearing highly concentrated, they're not saying it is the biggest thing imaginable or the most extreme object ever seen in every respect. They're talking about how mass is distributed, especially toward the center. A cluster can be enormous and still have a relatively loose core. Another can be less dramatic at first glance, and yet hold a surprisingly dense central region. Strong lensing is particularly sensitive to that central structure, which is why these observations carry so much weight. A good way to feel the difference is to imagine two hills made of the same amount of earth. One is broad and gentle, spread over a wide area. The other rises more steeply, with much of its mass gathered into a narrower summit. If you roll a ball past the first hill, its path bends a little. Past the second, the curve becomes harder, more decisive. Gravitational lensing works through far more intricate geometry than that, but the intuition is useful. Not just how much mass exists, but where it has gathered determines what the passing light will do. This is why a distant cluster showing strong lensing is not merely another entry in a catalogue. It means the cluster's inner gravitational terrain has already become serious. The core is doing enough work on the background light to produce repeated images and giant arcs. That, in turn, becomes a clue about the timing of structure growth. Not a final verdict, a clue. But clues at this scale are expensive. The universe does not give them away casually. One of the most intriguing examples in this broader conversation is a cluster known as XLSSC122. The name is cold, almost bureaucratic, which feels wildly out of proportion to what it represents. At a redshift of nearly 2, we are seeing it from a very early period in cosmic history compared to the present day, and yet it has been reported as the most distant galaxy cluster, then known to show strong lensing. That phrase alone carries an emotional charge if you let it. Not the most distant pretty object, not just another faraway cluster, the most distant cluster known, at that point, to bend background light so powerfully that it created the kind of strong lensing signatures astronomers rely on for detailed mass inference. Pause on that and the scale of the situation settles in. We are talking about a system whose light began its journey when the universe was far younger than it is now, and whose core was already able to act like a formidable gravitational lens. Not weakly, not ambiguously, strongly enough to produce giant arcs, strongly enough to invite modelling, strongly enough to force the question of how quickly some massive structures can become centrally concentrated. That does not mean all distant clusters behave this way. It does not mean every theory is suddenly suspect. It does mean that the old lazy version of the early universe as broadly soft and gravitationally underdeveloped starts to feel less trustworthy every time another such system is confirmed. A single striking case can be an outlier. Several begin to hint at a pattern. The scientific challenge is to determine which we are looking at. And that challenge is more subtle than it sounds, because clusters are not clean laboratory spheres. They are assembled through mergers, accretion, environmental history, and the complicated interplay between dark matter, galaxies, and gas. A mass model is not a photograph of dark matter. It is a reconstruction based on observed lensing features, redshift information, and theoretical form. The parameters astronomers derive depend on how the model is built and what spatial range is being emphasized. None of that weakens the result. It simply reminds us that real knowledge is often sharper and more careful at the same time. That care makes the discovery stronger, not weaker. It means the surprise has survived contact with method. And the surprise, at its core, is this. Some clusters in the distant universe seem to have inner structures that are more legible, more potent, and in some cases more concentrated than many non-specialists would ever expect. Webb did not invent that fact. Gravity had already written it into the sky, but Webb has been giving us more of the writing to read. There is something almost intimate in that phrase, more of the writing to read, because it captures what these observations feel like when they are handled honestly. This is not a conquest story. We did not force the universe to yield. We built an instrument capable of noticing patterns that were always there, faint and ancient, and then we trained minds on those patterns until hidden structure began to emerge. That is a much more beautiful thing than domination. It is participation. A conversation across time with light as the messenger and gravity as the grammar. You can feel that grammar most clearly in the arcs themselves. They are not just curved because curvature looks dramatic. They curve because the paths available to the light have been warped by mass. They repeat because the geometry of the lens permits multiple routes from one source to one observer. They brighten and stretch near critical regions because the gravitational field there is doing something specific, not mystical. If you know how to read those distortions, they tell you where the hidden scaffolding must lie. And once you start calling it scaffolding, the whole history of the universe changes tone. The visible galaxies stop being lonely islands and start looking like lit rooms inside a much larger structure. Dark matter, whatever its ultimate nature turns out to be, becomes less of an abstract inventory item and more of a shaping presence. Not visible in itself, but visible in consequence. Like wind moving through leaves, like pressure revealed by the way a door flexes in its frame. We do not watch the invisible thing directly. We watch the pattern it forces onto everything else. That mode of seeing is one of the deepest themes in science. Some of the most important realities are known not by direct confrontation, but by disciplined inference. We do not see the Earth's magnetic field with bare eyes, but we can watch iron filings align. We do not see air itself in a still room, but curtains move, skin cools, sounds carry. In the same way, we do not see a cluster's dark matter halo as an object in the ordinary visual sense. We see what it does to passing light, and the distortion becomes the evidence. Now place that evidence in the context of youth. That is where the emotional force sharpens again. Because youth, to us, is usually a period before structure hardens, before the center holds, before systems accumulate enough weight to redirect other things around them. But in these remote clusters, gravity is already in command. Not everywhere, not uniformly, not in a way that turns the young universe into a finished cathedral, yet in certain places, unmistakably, the center already holds enough to bend background galaxies into repeated signatures across the sky. And that should make the universe feel different. Not bigger, exactly. It was already bigger than feeling can manage, more decisive, perhaps, more active, less like a mist waiting to become reality, and more like reality already sorting itself into deep wells and powerful structures while time was still young by cosmic standards. The early universe, seen this way, is not merely a prelude. In some regions, it is already making heavy commitments. Which brings us back to Webb itself, and to why this telescope has become such a potent instrument for changing not just datasets, but intuition. It is easy to describe a telescope as a machine that looks farther. That is true as far as it goes, and nowhere near enough. Webb is also a machine for making distant structure legible in a different wavelength regime, under conditions where the oldest and faintest galaxies are no longer lost so easily in the glare and crowding of the field. It helps turn the background into evidence, and when the background becomes evidence, the foreground cluster stops being a silhouette and becomes a map of hidden mass, a map of assembly, a map of how quickly gravity learned to make itself visible through distortion. The longer you sit with that, the more radical it feels that our species can do this at all. Not because humans are grand, but because the act itself is so improbable. A primate on a small planet studies warped infrared light and infers the interior structure of a cluster billions of light years away. That is not normal in any ordinary sense of the word. It is one of the strangest things that consciousness has ever managed, and it only becomes stranger when the thing being inferred turns out to be more organized, earlier than our own instincts were prepared to accept. So the story is no longer just about what Webb saw, it is about what the seeing means. And the meaning continues to deepen as we ask the next necessary question. If this hidden architecture is becoming clearer, what kind of universe must exist behind it for such order to appear so early at all? To answer that, we have to step back from the image without losing what the image taught us. The arcs matter because they are local clues, but those clues point into a much larger process, the growth of structure across cosmic time. And structure growth is one of those phrases that can sound dry until you translate it back into reality. What it really describes is the universe learning where its weight is. In the beginning, matter was not arranged as clusters, galaxies, stars, or planets. There were tiny differences in density, minute irregularities in the distribution of the matter and energy in the young cosmos. Those irregularities were small, but gravity is patient and merciless with small advantages. A region that is slightly denser pulls slightly harder. Pulling slightly harder means gaining slightly more matter. Gaining slightly more matter means becoming denser still. Over immense spans of time, the imbalance compounds. What begins as a whisper becomes a basin. What begins as a basin can become a halo, and halos, under the right conditions, become the gravitational homes of galaxies and clusters. That overall story is not in doubt. The universe builds through growth from initial fluctuations, but the pace, the details, the concentration of mass in particular systems at particular times, that is where observation matters. Theory can tell us what should generally happen. The sky tells us what actually did happen in specific places. When the two line up, confidence grows. When the sky reveals something sharper or earlier than our rough intuition expected, we do not throw away the framework. We examine the assumptions we smuggled into it. One of those assumptions is emotional rather than mathematical. We imagine growth as gradual in a way that is almost gentle, but gravity is not gentle. It is cumulative. It does not need drama to become overwhelming. Given enough matter and enough time, it builds depth with relentless monotony. There is something unsettling in that, because it means the universe can produce extreme structures without any theatrical break from its own rules. A cluster core capable of strong lensing at great distance does not require the cosmos to behave irrationally. It only requires us to admit how effective the ordinary rules can be. Still, the distance matters. It matters enormously. When we talk about a cluster at a redshift near 2, we are peering back to a time when the universe was only a fraction of its current age. That phrase can sit in the mind as a number if we let it. Better to make it personal. If the age of the universe today were compressed into a human lifetime, say 80 years, then we would be observing that cluster as it was in something like adolescence, not old age, not infancy, but far from settled. And yet the gravitational center is already strong enough to bend the deeper background into giant arcs. That does not feel like a late arrival, it feels like an early declaration. There is a temptation here to imagine structure growth as a kind of cosmic skyline rising evenly over time. A few low buildings, then more, then a dense downtown. But the universe is less fair than that. It is patchy, uneven, hierarchical. Some regions gather more quickly. Some halos deepen earlier. Some become crossroads of mass sooner than others. That unevenness is part of what makes distant lensing clusters so revealing. They are not telling us the whole universe was equally mature. They are telling us that in at least some privileged regions, gravity had already done remarkable work. This is where cluster studies stop being just about objects and start becoming about distribution. Not distribution in the bureaucratic sense, but in the emotional sense of where reality chooses to become intense. A lensing cluster marks one of those intensities. It is a place where matter has pooled hard enough to redirect the path of light from other galaxies. It is a place where the universe has already built a deep enough bowl that background reality curves around it. Once you think of clusters that way, as bowls in space-time rather than floating collections of galaxies, the image sharpens. A background galaxy is not simply sitting behind the cluster in a neat layered diagram. Its light is moving through a warped terrain. Some paths are bent more strongly than others. Some routes produce bright, elongated images. Some create separated twins or triplets. Some miss us entirely. What we observe is the subset of all possible paths that survive the geometry and happen to reach one telescope near Earth. The image is not the scene. It is the scene filtered through gravity. And that is why repeated patterns are such precious evidence. One arc may suggest lensing. Several related images can begin to constrain the lens. Many such systems can transform an attractive field into a rigorous map. This is exactly what Webb has been enabling with unusual force. In cluster after cluster, faint background galaxies that would once have been too difficult to pick apart have become visible enough to use. You might think of it as adding more stars to a constellation, except the stars are actually distorted copies of deeper galaxies, and the constellation they define is not in the background at all. It is the invisible mass in front. That is the hidden reversal. We look farther to understand what is nearer. We read the background to reconstruct the foreground. Ancient light from behind the cluster teaches us about the structure of the cluster itself. There is something beautifully indirect about that. Human beings often imagine knowledge as a straight line from eye to object. You look at the thing, and the thing becomes known. But much of the best science works sideways. You infer the shape of an atom from tracks in a chamber. You infer the interior of the Earth from seismic waves. You infer an exoplanet from the wobble of a star. And here, you infer the inner structure of a distant cluster from the way it injures the appearance of galaxies behind it. The distortion is the clue, the damage is the map. That way of seeing also protects us from one of the lazier reactions to this story, which is to turn the arcs into mere cosmic art. They are beautiful, yes, but their beauty comes from obedience, light obeying gravity, geometry obeying mass. The elegance is not decorative, it is evidentiary. Once that clicks, the emotional texture changes. We are no longer marveling at something exotic just because it is far away. We are watching order reveal itself through a very precise form of damage. And because the order is hidden mass, the story inevitably draws dark matter back into the center of the frame, not as a buzzword and not as a mysterious substance to be romanticized, but as a working part of the universe's architecture. Clusters are dominated by matter we do not see directly. The galaxies and hot gas matter deeply, but they do not account for the full gravitational field. The arcs are part of the evidence for that. They tell us the lens is stronger, broader, and more structurally rich than the visible galaxies alone would suggest. Again, careful phrasing matters. A mass map is not a photograph of dark matter. It is a reconstruction, a model constrained by real observations. But constraint is the key word. These are not fantasies laid over pretty images. They are disciplined attempts to describe the only kind of hidden structure that fits what the light actually did. When those reconstructions point towards substantial central concentration in a distant cluster, the implication radiates outward. It touches not just one object, but our general picture of how matter assembled itself in the earlier universe. If some cluster cores reach strong lensing potency by those epochs, then the path from primordial fluctuation to formidable gravitational well may have been more efficient in some places than the average mental picture suggests. Average mental pictures are usually the weakest part of our understanding. They trail behind the data, they preserve old simplifications, they cling to whatever image felt easiest the first time we heard the subject explained. For many people, the early universe still means formlessness. For many people, distance still means vagueness. For many people, Hidden mass still feels less real than bright galaxies because brightness is easier to love. Webb is quietly dismantling all three instincts at once. Far away does not mean unreadable. Young does not mean weakly structured. Invisible does not mean secondary. Those are not slogans, they are corrections. And once you accept them, you begin to see why the story carries so much emotional weight without needing any exaggerated language. A telescope in a deep space observes faint infrared light. Astronomers identify repeated images behind distant clusters. The geometry tightens. Mass models sharpen. Some faraway systems appear capable of strong lensing at epochs where many viewers would have expected looser, less settled cores. The universe becomes more active, more decisive, more legible in its youth. That alone would be enough to hold attention. But there is another layer beneath it, one that makes the whole story feel more intimate than a tale about galaxy clusters has any right to feel. Every one of these results depends on the fact that pattern can survive a long journey. Light can leave a background galaxy billions of years ago, cross expanding space, pass through a massive cluster, get bent into multiple routes, and still arrive in a form coherent enough for minds like ours to decode. Reality remains readable even after being stretched, delayed, and distorted across cosmological distance. That is not just a scientific fact, it is a statement about the universe we inhabit. It is a universe where order can hide inside damage, a universe where distance does not erase structure, a universe where ancient light can still be interrogated like fresh evidence. And the more Webb adds to that evidence, the more difficult it becomes to maintain the old emotional picture of the early cosmos as a place too immature for strong, elegant gravitational signatures. Some of those signatures were already there, waiting in the dark, long before there was anyone to call them surprising. Long before there was anyone to call them surprising, gravity was already doing what gravity does best. It was taking slight advantages and turning them into destiny. It was separating the universe into shallower places and deeper places, into regions where matter passed through and regions where matter began to gather, hold, and command. By the time the light from these distant clusters started toward us, some of those deep places had already become strong enough to reorganize the appearance of everything behind them. There is a hard honesty in that. The universe does not wait for consciousness before it becomes structured. It does not need an observer to begin shaping itself. Yet once observers do arrive, once a species appears that can build instruments and compare images and calculate trajectories, a strange reversal becomes possible. We enter very late, but we can still read what happened early. We do not witness those ancient epochs directly as living participants. We witness them through aftermaths, distortions, and delayed light, and sometimes that is enough to recover something almost startlingly precise. That precision is worth dwelling on because it rescues the whole subject from vagueness. It is easy to say that a cluster bends light. It is much harder, and much more impressive, to say that astronomers can use the positions of multiple lensed images to reconstruct the distribution of mass in the cluster's inner regions. The first statement sounds like a fact. The second sounds like a capability. Webb has been expanding that capability. Picture a sheet of paper with a photograph printed on it. Now imagine folding and warping the sheet without tearing it, bending different regions more strongly than others. If you looked at the final warped result without seeing the hands that shaped it, you might still be able to infer something about where the folds were deepest and how the paper had been pulled. That is not a perfect analogy, because lensing involves curved space-time rather than bent paper, and light paths rather than ink. But the intuition is useful. The distorted image is a record of what intervened. That is why the background universe matters so much in these fields. The cluster itself is not the only actor. The more distant galaxies behind it are the test pattern, the source material, the set of lights shining through the warped glass. If Webb reveals more of them, fainter ones, redder ones, smaller ones that older instruments could not separate as confidently, then the whole lens becomes easier to solve. Not easy, but easier. The unseen scaffolding begins to gather edges, and once the edges gather, you can start asking sharper questions about the core. How steep is the central mass profile? How much does the cluster-scale halo contribute relative to the embedded galaxies? Where do the strongest distortions line up relative to the visible members of the cluster? Are there offsets that reveal a more complicated history, perhaps mergers or substructure? How much of the inner landscape looks smooth, and how much looks clumpy? In a less precise era, some of these questions would remain largely speculative. With more constraints, they become testable. This is part of why the phrase unexpected symmetry should not be taken as a mystical claim. The symmetry is not a declaration that the universe has suddenly become more perfect than we thought. It is the repeated appearance of structure where casual expectation predicted less. It is the symmetry between multiple images of the same background source. It is the symmetry between what one arc implies and what another arc confirms. It is the symmetry between visible distortion and invisible mass. A kind of alignment between what the eye sees and what the model infers. That layered meaning matters because otherwise the title can be misunderstood. The real surprise is not that distant clusters are pretty. The surprise is that some of them are readable in ways that carry real consequences for our picture of early assembly. And assembly is the word that keeps growing in importance the longer we stay with this, not because it sounds technical, but because it cuts against the emotional image people tend to carry. Assembly suggests process. It suggests pieces becoming a system. It suggests that there was a before and an after, a period when matter had not yet pulled deeply enough, and a later period when it had. When we find evidence that certain distant clusters were already powerful, strong lenses, we're catching that process farther along than many people would have guessed. There is a useful discipline in separating what this does and does not mean. It does not mean that the whole universe sprang into maturity all at once. It does not mean the early cosmos was uniformly rich in cluster cores this concentrated. It does not mean every model fails. What it means is narrower and, for that reason, more compelling. In some places, at some times, gravity had already built central structures robust enough to do extraordinary optical work on the background sky. Once you admit that, the simplistic version of cosmic youth has to go. You can feel the force of that if you compare it to human development. A person in adolescence is not a finished adult, but neither are they a blank sketch. The bones are there, the centre of mass is there, the mind has structure even if it is still changing. Something similar, very loosely speaking, applies here. A cluster seen at great distance may not represent the fully evolved state of such systems in the later universe, but it can already possess decisive features. It can already have a deep enough gravitational centre to bend the paths of light in dramatic, legible ways. That makes these observations feel less like glimpses of infancy and more like glimpses of momentum. Momentum is a different emotional category from youth. Youth invites condescension, softness, underestimation. Momentum invites respect. A system with momentum is not merely present. It is already becoming more of itself. The distant cluster that produces giant arcs is telling us exactly that. By the time we see it, it is already deep in the work of being a cluster in the strongest gravitational sense. And that opens a wider reflection on what we mean when we say the universe is evolving. We often imagine evolution as smoothing, settling, finishing. But gravity often evolves by amplifying contrast. The dense become denser, the deep become deeper, the bowl sharpens, the roots of falling matter become more selective. In that picture, a strong lens is not only a passive sign of mass, it is evidence that contrast has grown teeth. You can almost see those teeth in the arcs. Not sharp teeth, of course, but gravitational ones. The sense that space-time itself has been given enough shape to seize passing light and pull it into curves that would have been impossible in a flatter terrain. What begins as a gentle metaphor about warped glass suddenly has force. The cluster is not only there, it has influence. It has enough influence to edit the background universe before that background reaches us. That is a strange kind of power. It is ancient, silent, and completely indifferent to whether anyone notices. For billions of years, those distortions simply existed as outcomes. Then a species on Earth built a telescope sensitive enough to detect them cleanly and patient enough to compare them against models of hidden mass. The cosmos did not become more structured when we looked. It became more confessed. There is something deeply calming in that, oddly enough. Not because the universe is comforting, but because it is intelligible beyond what our ordinary lives prepare us for. Daily life trains us to think in surfaces. We judge strength by visibility, age by appearance, significance by brightness. Cluster lensing undermines all three. The strongest thing in the image may be the least visible. The earlier epoch may be more organized than our instincts allow. The most important feature may be a pattern of damage in the light of something even farther away. No wonder these observations carry such quiet force. They do not merely add information, they revise what counts as obvious. And once the obvious begins to change, the deeper time dimension of the story becomes unavoidable. Because when Webb looks at these clusters, it is not just showing us distant structures, it is placing our own present inside a much older chain of events. The arcs exist because background galaxies emitted light. That light travelled for billions of years. It crossed the gravitational field of a cluster that had already assembled a concentrated core. Then it continued onward until a telescope in the 21st century caught it. The image is a collaboration between timescales so far apart that the human mind struggles to keep them in one thought. A galaxy emits, a cluster bends, a telescope receives, a mind infers. That sequence alone is enough to make reality feel less ordinary. And there is still another layer coming into view. Because if the observation of these clusters already forces us to revise our feeling for early structure, then the next question is not only how concentrated some of these systems were, it is why that concentration matters for the larger story of what the universe was becoming, and what we were never supposed to be able to see so clearly from this far inside it. Why does it matter? Because concentration is not just a detail in the anatomy of a cluster. It is a clue about tempo. It tells us something about how quickly matter, under the influence of gravity, can move from being merely abundant to being centrally consequential. A diffuse structure can be large without becoming an especially powerful lens. A concentrated one changes the geometry of the sky behind it. So when Webb helps reveal cluster cores at great distance that are already doing this work, the implication spreads outward. We are not only learning that these objects exist, we are learning something about how early serious gravitational depth can arise. That matters in cosmology for the same reason riverbanks matter in a floodplain. Water may be everywhere, but where it cuts deep channels tells you where the force is concentrated and where the landscape is being decisively shaped. In the cosmic version, dark matter halos and cluster cores are those channels. They are the places where the broader story of structure formation becomes sharp enough to redirect the motion of everything around them, including light. There is a technical side to that, of course. Astronomers use models for how dark matter halos should look on average, how their density changes with radius, how concentration might evolve with mass and redshift, how mergers complicate the picture, how baryonic matter, the ordinary matter in stars and gas, modifies the inner regions. But beneath all that detail sits a simpler emotional truth. The universe can hide an enormous amount of its history in the steepness of a well. A deep well changes everything that passes near it. That is what strong lensing feels like once the idea really settles. Not a trick of perspective, not a photographic flourish, a declaration that the well is already deep. The reason one distant cluster can attract so much attention is not because it single-handedly rewrites the universe. It is because it acts like a pressure point. Push on it, and larger questions move. How rare are such systems? Are we only now finding them because Webb can finally see the necessary background sources? Were they undercounted before, hidden in data too shallow or too crowded to decode cleanly? Do these concentrated cores represent the normal tale of expected structure formation? Or do they suggest that some regions assembled especially fast? At this level, the observation becomes an invitation to improve the whole census of cosmic architecture. That census matters because a single object is always tempting and dangerous at once. Tempting because the mind loves a vivid example. Dangerous because the mind then wants to turn the example into a verdict. Good science lives in the space between those impulses. It honors what is striking without pretending that one result carries the burden of all truth. In this case, the striking thing is plain enough. Webb is making distant cluster lenses more legible, and in doing so it is sharpening our sense that substantial gravitational structure existed earlier and more clearly than casual intuition suggested. That is a big enough revelation on its own, and it becomes even richer when you remember that a cluster lens does two things at once. It distorts, yes, but it also magnifies. The same mass that bends the background light can make otherwise unreachable galaxies easier to study by enlarging and brightening them. So a cluster is not only a hidden object being reconstructed through lensing, it is also a kind of natural observatory, an imperfect and powerful gravitational instrument that lets us peer deeper into the universe behind it. There is a beautiful reversal in that. The cluster hides itself by being mostly dark, yet through lensing, it helps reveal galaxies even farther away. It becomes both obstacle and aid, both mystery and tool. Its gravity interferes with the clean appearance of the background sky, but that interference can pull more distant structures into view, a magnifying glass with scars in the lens, a damaged window that still lets you notice something beyond it that you would otherwise have missed. The emotional texture of cosmology often comes from exactly these reversals. The thing that blocks also reveals. The distortion that seems to ruin an image becomes the clue that lets you reconstruct an invisible world. The distant object that looks like a problem turns into a solution. Webb's observations of cluster lenses fit that pattern perfectly. The more carefully we study the interference, the more the universe begins to explain itself through it. This is one reason the story does not collapse into technicality, even when the science becomes demanding. The underlying logic remains human. We all understand, at some level, that you can learn from a trace. Mud on a floor tells you someone entered the room, a bent fence tells you where force was applied, a crack in plaster tells you about the weight behind the wall. Strong lensing works at a scale almost impossible to emotionally contain, but the logic is the same. The arcs are traces. The repeated galaxies are traces. The curved light is a crack in the surface of appearance. And when the trace is this large, it points to something large in return. That is why the phrase hidden architecture belongs here so naturally. Not because it sounds elegant, but because it is exactly what these observations are revealing. Architecture is not simply matter present in space. It is matter arranged in a way that channels consequence. A pile of stones is not architecture. A load-bearing arch is, in the same way, a cluster core that is concentrated enough to produce strong lensing is not just a quantity of mass. It is an arrangement. A configuration that does work on the light behind it. That distinction deepens the feeling of surprise. The older emotional picture of the early universe is not only that it should be younger, but that it should be less architecturally advanced, more raw material, fewer finished load-bearing forms. What Webb is helping to show is that some of those load-bearing forms were already there, not complete in every sense, not representative of every region, but real enough to leave unmistakable signatures across the sky. You can feel the human significance of that in a very small way. Think of walking through a city before dawn. Most windows are dark, the streets are quiet. At first glance, the place feels asleep, almost unfinished in the absence of activity. But then you notice the bridges, the retaining walls, the transit lines, the hidden systems already in place beneath the calm. The city is not waiting to become structured. The structure is already there, carrying the possibility of everything that will happen later. In a distant cluster, strong lensing offers a cosmic version of that realization. The visible scene may look sparse compared to the crowded nearby universe, but the hidden support system is already formidable. That is one of the reasons this subject is so strangely calming. It reveals intensity without requiring chaos. It reveals depth without demanding spectacle. The arcs are dramatic, but the underlying message is almost serene. Gravity has been at work for an immense time, and in some places it had already built enough concentrated structure to leave a clean, repeating signature in the background universe. There is no panic in that, only a change in scale, a change in what counts as early, a change in what counts as visible. And that change reaches all the way back into how we imagine the act of observation itself. Because what Webb is really doing, in scenes like this, is teaching us that seeing is not the same as receiving untouched light. Often the most meaningful observations are the ones where light arrives altered, filtered by gas, stretched by expansion, shifted into infrared, bent by gravity, separated into multiple routes. Observation is not the recovery of purity. It is the disciplined interpretation of what survived the journey. That has always been true in astronomy, but lensing makes it impossible to ignore. You're not seeing a background galaxy as if nothing stood between you and it. You're seeing what the universe allowed after a cluster intervened, and still, from that intervention, a deeper truth emerges. The foreground cluster becomes knowable, the background galaxy becomes magnified, and the relationship between the two becomes a measure of hidden mass and cosmic time. 3 layers of reality in one image, 3 distances speaking at once, 3 acts of interpretation braided together. The longer you sit with that, the more remarkable it becomes that the whole thing can remain so visually quiet. a field of faint red smears, curved streaks, and soft glows does not look like a revolution in perception. It looks almost gentle. Yet behind that gentle appearance is a profound correction. The deep universe is not simply a place where things disappear into vagueness. It is a place where structure can declare itself through distortion, where hidden mass can be reconstructed from repeated light, and where cluster cores can already possess enough depth to challenge our emotional picture of youth. And that challenge becomes stronger when we stop thinking only about the objects and start thinking about what it means that our minds can follow the evidence at all. Because buried inside every lens model, every matched image system, every sharpened mass map is an act of trust in pattern, the belief that reality, however warped, still leaves enough coherence behind for intelligence to read it. That trust in pattern is one of the quiet foundations of science. It is so basic we rarely stop to feel how strange it is. We assume that if the universe has been distorted, delayed, stretched, scattered, or hidden behind some intervening structure, there may still be enough coherence left in what arrives for us to reconstruct what happened. That assumption is not naive optimism. It is a wager that reality, even when damaged in transit, is not reduced to nonsense. Cluster lensing is one of the purest vindications of that wager. The background light has not come to us cleanly. It has crossed billions of years, expanded with the universe, and then passed through the gravitational field of an enormous foreground structure. By any ordinary emotional standard, that should be too much interference, too much time, too much distortion, too many opportunities for the original scene to become unreadable. And yet it remains readable enough that repeated image systems can be identified, mass models can be built, and the hidden structure of a distant cluster can be inferred with serious precision. There is a lesson in that, and it runs deeper than astronomy. We often equate clarity with simplicity. We think something must arrive untouched in order to be known, but nature is not obliged to present itself in pristine form. Often the opposite is true. The interference is the clue, the damage is the evidence, the distortion is the signature of the thing we most need to understand. That is exactly what makes these Webb results so satisfying. The telescope is not merely providing us with prettier examples of a phenomenon we already understood in a broad way. It is intensifying our access to the phenomenon by increasing the amount of usable pattern in the field. More faint background galaxies, more multiply image systems, more geometry, more pressure on the model, more opportunities to test where the mass must be, and how deeply it has already pulled toward the core. And that last point keeps carrying weight the longer we stay with it. Because a core is not just a center is a geometric idea, a core is a physical condition. It means matter has not only assembled, but assembled in a way that creates a strong inner regime, a place where the gravitational landscape becomes steep enough to dominate the paths of passing light. When a cluster at great distance shows this behavior clearly, it is telling us something very specific. By that time, in that place, the universe had already built more than a loose gathering. It had built a serious well. There is an emotional difference between a gathering and a well. A gathering is temporary. A well changes trajectories. A gathering exists. A well commands. Strong lensing belongs to wells. This is why concentration feels so much more important than it first sounds. The word can seem almost administrative, as if we are merely filing information about how compact something is. In reality, it speaks to the effectiveness of a structure. How decisively does it curve the space around it? How much authority does the center already have? A distant cluster with a powerful core is not just another object in the sky. It is a sign that gravity, by that epoch, has already done something more irreversible than our instincts expected. That idea becomes especially potent when you remember how clusters grow. They are not dropped into existence whole. They assemble hierarchically, through the accumulation of smaller structures, through mergers, inflow, and the deepening of dark matter halos over time. There is history in every core. There are former outskirts now buried in the center. There are older collapse events hidden inside later configurations. When Webb helps sharpen a mass reconstruction, it is not only showing us where the mass is, it is giving us a present tense clue about a long, earlier process of becoming. A lensing cluster is a record of assembly written in force, and force leaves a particular emotional trace. It makes the universe feel less decorative and more consequential. The arcs stop looking like accidents of perspective and start looking like verdicts. Not verdicts on all cosmology, not declarations that one model lives and another dies, but verdicts on a local fact. The light did this because the mass was there in this way. The geometry happened because the core had become this deep. There is no way around that. Every time a repeated image is correctly identified, the freedom of interpretation narrows. That narrowing is part of what makes the science so compelling to listen to. It is not just a story of surprise, it is a story of reality becoming harder to evade. If you think about it from the standpoint of a human lifetime, the scale becomes almost absurd. Most of what matters in our personal lives takes shape over years. Relationships, habits, grief, work, memory, physical change, even the longest civic projects that most of us witness, bridges, cities expanding, forests regrowing, sit within the span of decades. Here, by contrast, we are reading the assembly of structures across billions of years through the fate of light that arrived only now. The time compression is extraordinary. Ancient outcomes become contemporary evidence. And yet the mind can still follow it, because the logic is concrete. One source becomes multiple images. Multiple images imply a lens. The lens geometry constrains the mass. The mass concentration speaks to the state of structure growth at that epoch. No single step is mystical. The wonder comes from the sequence holding together across such impossible distances. That coherence is one of the reasons these observations feel different from vague cosmic awe. They do not ask us to be overwhelmed by size alone. They ask us to admire the fact that the universe leaves evidence. Not simple evidence, not always easy evidence, but evidence robust enough that a distant cluster can become legible through the distortions it imposes on light from beyond itself. And once a cluster becomes legible that way, it changes the emotional status of the background sky too. The galaxies behind the lens are no longer just scenery. They become participants in a measurement. Their light is both victim and witness, bent, stretched, multiplied, but in exactly those injuries, useful. That is one of the most beautiful inversions in the whole subject. The background object does not lose scientific value because it has been distorted. It gains another kind of value. It starts telling us about the foreground universe as well. Everything in the image becomes relational. The cluster is understood through the galaxies behind it. The galaxies behind it are made more visible by the cluster. The telescope depends on both. The interpretation depends on pattern across all of them. That is not a pile of facts. It is a woven system. And systems like that are what make the cosmos feel most alive. Not alive in a biological sense, of course, but alive as an intelligible order, one level of structure revealing another, one layer of consequence making the next readable. When people hear about dark matter, they often imagine a single mystery standing outside the ordinary flow of astronomy, as if the hidden mass were a separate puzzle box. But in cluster lensing it becomes something more grounded. Dark matter is not a rumour at the edge of the frame. It is woven into the working structure of the cluster. You do not need to indulge in speculation to feel its importance. You simply follow the lensing evidence. The visible galaxies alone do not explain the full gravitational field. The gas alone does not either. The larger hidden halo has to be there, not as an article of belief, but as the kind of structure that fits what the light actually did. This is another reason why the story remains so powerful even when told carefully. Caution does not diminish it. If anything, caution lets the strangeness become more durable. We do not have to say the universe has become impossible. It is enough to say that Webb is sharpening the evidence that some distant clusters possess unexpectedly legible, centrally potent gravitational structure, that some of the young universe's massive systems were already capable of doing intricate optical work on the background sky. That hidden architecture was already in place far enough back to unsettle the old emotional shorthand of young equals loose. The shorthand collapses, the evidence remains, and what remains has a distinct texture. It is not loud, it does not demand theatrical language, it is quieter than that, and stronger for being quiet. The deep universe is not merely a graveyard of ancient light fading into abstraction. It is a place where ancient light can still be bent into readable signatures by structures that had already accumulated real authority. We are not looking at a vague preface to cosmic history. We are looking at a chapter in which some of the load-bearing forms were already present. That realization begins to change the feeling of deep time itself. Instead of imagining the past as a featureless retreat into simplicity, we begin to imagine it as uneven terrain, with pockets of surprising maturity, places where gravity has already been hard at work creating centres, wells, and concentrated regimes. The farther we look, the less justified it becomes to treat the past as uniformly unfinished. And that leads naturally to a more difficult kind of intimacy. Because if the past was already this structured in places, if ancient light still carries enough pattern to reveal it, and if our instruments are now subtle enough to read those patterns, then the distance between us and those clusters is not only one of scale, it is also one of relation. We are, in a strange and disciplined way, in contact with them through geometry. In contact through geometry, that may be the most honest way to describe what this kind of observation feels like. Not close in any ordinary sense, not emotionally intimate in the way a human life is intimate, but related through an exact pattern of cause and effect. A background galaxy emits light, a cluster bends it, we catch the altered result. From that altered result, we infer the hidden mass that intervened. Across billions of years, a relationship forms, no conversation. No awareness on the part of the cluster, just lawful connection, and somehow that is enough. It is enough because geometry is one of the few things distance does not destroy. Brightness fades, detail softens, time stretches, meaning thin. But geometry, if you can recover it, keeps a kind of skeletal truth. A repeated image remains repeated, a curved arc still points back toward the field that bent it. The paths taken by a light still remember the shape of the gravitational terrain they crossed. That memory is what Webb is helping us access more clearly. There is something almost startling in the modesty of the mechanism. We are not using magic. We are not penetrating the universe with some impossible direct sight. We are watching what light had to do, that is all. Yet in that all sits one of the deepest scientific powers humans possess, the ability to infer hidden structure from visible consequence. Much of mature knowledge works this way. We learn not by demanding perfect exposure, but by reading the pressure a hidden thing exerts on what we can observe. Cluster lensing is that principle enlarged to an absurd scale. And because the scale is so absurd, the mind needs repeated footholds. So bring it back again to the simplest version. You hold a spoon in a glass of water. The spoon looks bent where it enters the surface. A child sees that and may think the spoon changed. Later, the child learns that the path of light changed instead. The object stayed what it was, but the medium intervened. Cluster lensing is vastly more extreme and profoundly more beautiful, but the same mental correction is required. The arc is not a new galaxy invented by Webb. The mirrored fragments are not separate creations. The path changed. The mass intervened. The light remembers. Once you say the light remembers, the emotional core of the subject sharpens, because memory is usually something we reserve for minds, for nervous systems, for living beings carrying the past inside them. Here, memory belongs to a path, to a beam of light whose route was altered by a foreground cluster long before Earth had oceans like the ones we know now, and which still arrives carrying enough of that alteration for us to notice. It is not memory in the human sense, but it is history preserved in form. That preservation is what makes these observations so rich. They are not merely snapshots. They are records of interaction. A lensing field contains multiple times at once: the epoch of the background source, the epoch of the foreground cluster, the present moment of observation, and the vast transit in between. Webb collects all of that into one quiet image. The human achievement lies in refusing to leave it quiet, in insisting that the curved light means something, in being patient enough to match one faint arc to another and say, with discipline rather than fantasy, these are the same source, seen through different routes, and therefore the hidden mass must be arranged in a way that makes those routes possible. That last phrase matters because it shows where the real authority of the observation comes from, not in aesthetic reaction, but in necessity. The mass must be arranged in a way that makes those routes possible. There is no looser way to say it without losing the force. Lensing is powerful because it compels. Once the repeated images are correctly identified, the geometry starts closing doors. Some mass distributions stop being plausible. Others survive. Reality narrows. And when reality narrows around a cluster core in the distant universe, it tells us something more than local. It tells us that by that time, in that region, matter had already gathered into a strong enough arrangement to exert clear optical power over the background sky. That is not a poetic flourish. It is a statement about physical maturity, not universal maturity, not final form, but enough internal development that the cluster is already making the deeper universe curve around it. A phrase like optical power can sound almost too human, as if we are assigning intention to gravity. Better to say influence, but influence itself has emotional weight. We live most of our lives inside small fields of influence. The influence of a room on our mood, a family on our habits, a city on our pace of life, a decade on what seems normal. In cosmology, influence becomes harder to feel because the agents are so huge and impersonal. Yet cluster lensing restores some of that felt sense. The core influences the background. It edits appearance. It decides, in a purely gravitational way, which paths of light arrive magnified, which arrive stretched, and which miss us altogether. The universe is full of such editing. Most of it goes unnoticed by human bodies because we evolve for slower, smaller scales. Webb does something extraordinary by making one form of that editing visible enough to study in detail. And in doing so, it gives us back a more realistic feeling for the early cosmos. Not a nursery of half-made structures, but a stratified landscape where some wells were already becoming profound. That change in feeling may sound small, but it is not. Emotional pictures are the skeleton of public understanding. People can memorize facts and still imagine the wrong universe. They can know, in principle, that galaxies and clusters formed over time, and still carry a background image of the distant past as thin, shapeless, and weakly organized. A single strong lensing cluster at great distance does not erase complexity, but it does strike directly at that background image. It says, no, by then, at least here, gravity had already built something that could seize light. That is one of those moments where a scientific result becomes more than information. It becomes a correction in imagination. And imagination matters because it is where meaning settles. If the imagination remains wrong, the facts drift off as isolated trivia. If the imagination changes, the facts begin to live together. In this case, the corrected imagination is a universe where hidden structure emerges early in uneven but powerful ways, where the invisible can dominate the visible, where distance does not necessarily mean vagueness, and where distortion is often the route to understanding. Each of those corrections makes the next one easier to accept. Once you accept that invisible mass can dominate the visible field, then it becomes easier to understand why the arcs matter more than the bright galaxies at first glance. Once you accept that distortion can preserve pattern, then it becomes easier to understand why repeated images are gold for reconstruction. Once you accept that some distant clusters already possess strong, concentrated cores, then it becomes easier to abandon the childish version of the young universe as merely loose. And once you accept all of that together, the title changes meaning again. Unexpected symmetry is no longer just what the eye notices in the image. It is what the universe kept despite distance, despite distortion, despite hidden mass, despite time. A kind of order that survives enough interference to become legible here. That survival invites a more reflective question. Why should reality be this readable at all? Not why should it obey laws? Science begins there and works forward. But why should lawful structure remain recoverable across such damaged, delayed, transformed conditions? Why should a background source lensed by a distant cluster billions of years ago still contain enough usable pattern that minds on Earth can reconstruct the invisible core that bent it? There is no mystical answer needed. The practical answer is that physics is stable, light follows space-time, and the universe preserves consequence. But the emotional answer is harder to ignore. We live in a cosmos that leaves tracks. It does not hide its history perfectly. It bends, stretches, reddens, and delays the evidence, but it does not erase it. Webb's great gift is not only that it reaches far enough, cleanly enough, that those tracks begin to stand out where many people once expected only darkness and blur. And as soon as you start thinking in terms of tracks, you begin to see why these clusters matter beyond their own images. They are not just distant objects. They are proof that the deep universe can be investigated through consequence, that hidden architecture can be reconstructed from bent light, and that some of the largest structures in the cosmos were already asserting themselves much earlier than our casual emotional models were prepared to believe. Prepared to believe? That phrase matters because belief, in ordinary life, is often treated as a soft thing, a matter of taste or temperament. In science, belief hardens only when evidence accumulates in ways that leave less and less room for comfortable alternatives. The distant cluster lens does exactly that. It does not ask us whether we like the idea of early hidden structure. It presents the altered light and says, account for this. Explain the arcs. Explain the repeated images. Explain the magnification. Explain why the geometry works. And once you do, the old emotional shorthand gives way. That is one reason the best astronomical discoveries do not feel like fireworks after a while. They feel like pressure, a slow, clean pressure on assumptions we did not realize we were carrying. Webb's observations of distant clusters have that quality. They do not need to shout. The evidence is patient. It keeps returning to the same point from different angles. Some of these systems are already gravitationally mature enough in their cores to act as strong lenses, and that fact is written into the background sky with a consistency that can be modelled and tested. The modelling itself is worth pausing on, not to get lost in technical detail, but to appreciate the intellectual posture it requires. Astronomers do not simply look at one arc and declare victory. They compare positions, shapes, colours, redshift estimates, plausible source associations. They test whether one candidate image really belongs to the same background galaxy as another. They examine how the cluster members contribute locally, while the larger dark matter halo shapes the broader field. They adjust models, reject mismatches, tighten fits, and repeat. There is patience in that. Not the patience of passivity, but the patience of someone listening very carefully in a noisy room. That listening matters because the universe is not eager to make itself easy. Cluster fields are crowded, light overlaps. Foreground galaxies can complicate the scene. Background sources are faint. The lens itself can contain substructure that makes the geometry richer and harder to untangle. There is no clean, theatrical reveal where the hidden mass steps out into full view. Instead, there is accumulation. Enough repeated evidence, enough consistency, enough surviving pattern that the invisible becomes constrained. Constrained is one of the most important words in this story. A constrained model is not fantasy. It is not pure interpretation. It is a disciplined description of what the universe allows. And the more Webb increases the number of usable constraints in a cluster field, the more the allowed picture sharpens. That is why the telescope changes the conversation even when it does not overturn the framework. It makes vague answers less acceptable. It turns broad possibility into narrower reality. We should feel the beauty of that, because it is very different from the cheap version of cosmic awe. Cheap awe says the universe is beyond us, incomprehensible, forever dissolving into mystery as soon as we approach. Real awe is almost the opposite. Real awe comes from discovering that the universe is deep beyond imagination and still leaves enough order behind for finite minds to follow. Not completely, not without uncertainty, but enough. Enough for a mass map, enough for a cluster core to emerge from distortions in light, enough for early structure to stop being an impression and become an inference. An inference is one of the great hidden achievements of civilization. It is easy to celebrate the image because the image is visible. It is harder to celebrate the mental act that turns the image into knowledge. But that act is where the real miracle lies, if we are going to use that word at all. The arcs by themselves are not a worldview. They become a worldview only when someone realizes they are not random, and then someone else realizes they can be matched, and then a model is built, and then the model survives contact with more data, and then a new telescope reveals even more of the field and the structure sharpens further. That is how understanding grows, not in speeches, in pressure, revision, and return. Once you feel that rhythm, the clusters themselves begin to seem less remote in a purely emotional way. They are still physically inaccessible beyond any practical meaning of the word, but they are no longer sealed off. Their hidden architecture has entered into relation with human thought, not because we mastered them, but because lawful consequence created a bridge. Light left one galaxy, crossed another structure, reached a telescope, and became geometry in a human mind. A gap of billions of years was not closed exactly, but joined. That joining reveals something else about the nature of scale. We often talk as though scale only diminishes us. A galaxy cluster is so large, so massive, so distant, that a human life seems negligible beside it. There is truth in that. But there is another truth as well. Scale also reveals what kind of beings we have become. Tiny beings. Yes. Brief beings. Absolutely. Yet capable of reconstructing the hidden mass profile of a structure billions of light years away by reading distortions in ancient light. Smallness does not cancel significance. Sometimes it sharpens it. This matters because the emotional ending of a story like this cannot simply be, the universe is big. That is true, and it is exhausted. The stronger realization is that the universe is big in ways that remain readable. And readability is more intimate than size. Size crushes. Readability invites relationship. Even a distant cluster can enter the field of human understanding if the traces are consistent enough and the tools are sharp enough. Webb has made those traces clearer. That is the deeper gift. It is also why the discovery has a kind of moral tone, though not in any preachy sense. The moral tone comes from restraint, from refusing to say more than the evidence warrants, while still letting the evidence be as astonishing as it truly is. It is astonishing enough that a distant cluster can reveal strong lensing. Astonishing enough that some such systems appear highly concentrated in their inner regions at epochs where many people's casual mental picture would expect less. Astonishing enough that the background sky can be turned into a measuring device for invisible mass. None of that needs embellishment. In fact, embellishment would weaken it. What the evidence suggests is already powerful. The universe did not have to wait until late times to produce gravitational structures of serious inner authority in every case. Some cluster cores were already capable of creating dramatic, organized lensing signatures much earlier than a non-specialist might comfortably imagine. That does not destroy cosmology. It makes cosmology more exacting. It asks for better measurements, broader samples, stronger statistics, and more careful thinking about the pace and diversity of structure formation. It turns the distant universe from a general backdrop into an active test of our models. That shift from backdrop to test is one of the quiet revolutions Webb keeps bringing. The early and distant universe is no longer just where we go to feel scale. It is where we go to measure how reality assembled itself. The arcs are not only spectacle, they are exam questions written in light. And a good exam question changes the student as much as it evaluates the theory. In this case, it changes the viewer. It takes the old image of the deep past as vaguely unfinished and replaces it with something less comfortable and more alive, a universe already full of asymmetry, hierarchy, and in some places remarkable gravitational concentration. A universe where hidden scaffolding existed early enough to imprint repeated curves on the light of still more distant galaxies. A universe that, far from becoming featureless with distance, sometimes becomes more revealing the farther we learn to look. That reversal stays with you. You begin with the idea that distance should erase. You end with the recognition that distance can disclose. You begin with the visible galaxies. You end with the hidden mass. You begin by thinking the arcs are decoration. You end by understanding that they are testimony. And testimony always points beyond itself, which means the final movement of this story is not only about what these clusters are, but about what it means that the cosmos preserves enough testimony for a late arriving species to read the shape of ancient gravity out of bent light. That phrase, ancient gravity, is worth holding for a moment. Gravity is always ancient in one sense. It belongs to the universe so deeply that we can barely imagine a reality without it. But in these images, gravity is ancient in a more specific way. We are not seeing what a cluster is doing now in some timeless present. We are seeing what its mass was doing to passing light billions of years ago. The arcs preserve an old active influence. The lensing field is a fossil of force. And fossils matter because they compress history into form. A footprint in stone is not the animal itself, yet something essential survives in the pressure left behind. A cluster lens works similarly, though on a scale so large it almost escapes comparison. The repeated images, the giant arcs, the stretched fragments of background galaxies, these are the pressures left behind by a gravitational landscape that ancient light once had to cross. The event is over. The evidence is here. That is why Webb's role is so consequential. It is not only extending our sight, It is improving our access to fossils of force. It is making those old pressures clearer, more numerous, more identifiable, more difficult to dismiss as visual clutter, and once they become readable, they start telling a story more specific than generic wonder. The story is that some distant cluster cores were already strong enough, already concentrated enough, already dynamically serious enough to impose a distinct and patterned transformation on the background universe. There is a sentence hidden inside that story that keeps gaining weight the longer you stay with it. Some of the deep universe had already become load-bearing. That is what concentration really means at an emotional level. Not just compactness, not just density, load-bearing structure. A part of the cosmic web that had already become strong enough to support consequence, redirect paths, and alter the appearance of things behind it. The visible galaxies are part of that structure, but not the whole. The hot gas is part of it, but not the whole. The dominant gravitational scaffolding reaches beyond what we can see directly. Yet it is real enough to leave repeating tracks. Once you think in terms of load-bearing forms, the distant cluster stops seeming like a mere accumulation of stuff and starts seeming like a developed piece of architecture. Rough in places, certainly. Possibly scarred by mergers, shaped by asymmetry, carrying substructure and dynamical history, but still architecture. Still a system whose arrangement matters more than its raw inventory. The arcs do not care that the cluster is photogenic. They care where the mass is. And if where the mass is can be inferred from how the light was bent, then an extraordinary reversal happens. We become able to learn about the invisible present of the cluster's past through the damaged appearance of something even farther away. That sentence sounds tangled because the reality is tangled, yet the logic remains clean. A background galaxy did not need to intend to become a probe. The cluster did not need to intend to become a lens. The interaction happened lawfully, and that lawfulness left enough pattern for us to use. It is difficult to overstate how unusual that is in human terms. Most of our species evolved to interpret nearby surfaces, faces, weather, movement through grass, the shape of a shoreline, the tension in a voice. Our brains are magnificent in those scales and profoundly underbuilt for cosmological ones. And yet, through mathematics, imaging, and patient comparison, those same brains can stretch their pattern reading outward until they are effectively reconstructing hidden mass at distances beyond any natural intuition. There is humility in that, but also a form of earned pride, not the pride of domination. The pride of having learned to listen carefully enough that the universe's distortions become intelligible. That listening is why this story remains emotionally powerful even in its most careful form. It would be easier, in a superficial sense, to turn the whole thing into a parade of dramatic claims. But that would flatten the actual beauty. The actual beauty is that the evidence is sufficient, not total, not final, but sufficient to shift perception. Sufficient to force a more serious imagination of the distant universe. Sufficient to make us feel that deep time was not a blank hallway leading towards structure, but a landscape where some powerful structures had already begun to assert themselves. This changes how the word early should feel. For many people, early means embryonic, weak, barely formed. In cosmic history, early can still include immense authority. Early can mean a universe in which the average conditions differ from the present. Yes, but where gravity has already taken certain regions very far along the road toward concentrated power. A strong lensing cluster at great distance embodies that correction with unusual force. It says that by then, in at least some places, the wells were already deep enough to take hold of ancient light and write their presence onto it. There is nothing abstract about that once you let yourself picture it. A background galaxy emits its light. Across unimaginable time, that light approaches a foreground cluster. Near the cluster core, space-time is curved enough that the light's route splits into several possibilities. Some paths are magnified, some are elongated, some sweep into arcs around critical regions where lensing becomes especially strong. Then, after all that, the altered light continues across the remaining abyss and reaches a telescope built by beings who did not exist when the process began. The telescope records, the analysts compare, the hidden mass begins to emerge. It is a sequence that should feel impossible, and yet it happened. Not once in some mythic singular event, but as a repeatable observational process, across multiple clusters, across multiple lensing fields, across enough systems that what was once mostly an image can become a pattern in a broader scientific conversation. That broader conversation matters because it protects us from the temptation to isolate a result into a spectacle. The real significance of distant cluster lensing is cumulative. One field reveals one hidden structure, another reveals another. A survey builds a set of comparisons. Webb identifies more multiply image systems than older data alone could confidently establish. Mass maps improve. Cluster cores become sharper in inference. Then, a particularly distant, strong lens appears, with an inner concentration striking enough to intensify the larger question of timing. Piece by piece, the sense of the early universe changes. Not shattered, clarified. That word is better than rewritten, because rewritten implies we were somehow beginning from nonsense. We were not. The framework of structure formation is powerful and successful. But within that framework, the universe still retains the right to surprise us in detail, in pace, in concentration, in how quickly some regions become dynamically imposing. Webb has entered exactly that territory. It is not tearing up the map. It is making the contour lines steeper in places where we did not yet feel how steep they were. And contour lines are a useful image here because strong lensing really does give us something map-like. Not a photograph of dark matter, not a direct portrait, but a topography inferred from consequences. This region must be deeper. This gradient must be strong. This part of the field can account for these arcs. This cluster member can perturb the local image geometry. The whole inner terrain takes shape the way a mountain range takes shape from shadows and survey lines before you ever climb it. There is a peculiar calm in knowing that the universe can be mapped this way. It means hidden things are not necessarily sealed things. Their presence leaks into the visible world through influence. If the influence is stable enough, and if the instrument is sharp enough, then the hidden thing becomes part of knowledge. That is the deeper promise fulfilled by these cluster observations. Not just that Webb saw farther, but that farther turned out to be more structurally articulate than many people were prepared to feel. And once you feel that articulation, the universe becomes harder to reduce. It is not only vast, it is patterned, not only old, active in its youth, not only luminous, dominated, in places, by what does not shine, not only beautiful, legible. That last word may be the most important of all, because legibility is what transforms astonishment into understanding. We can be stunned by scale and remain unchanged. We can admire colour and move on. But when reality becomes legible, perception itself shifts. The viewer no longer sees a decorative spray of distant arcs. The viewer begins to see testimony from a gravitational architecture old enough to predate Earth and strong enough to leave orderly marks in the background sky. Those orderly marks are what stay with you, because they force a kind of reversal in how we usually experience evidence. In ordinary life, order often reassures us. Straight lines, repeated forms, symmetrical rooms, familiar faces, they create the feeling that things are under control. But in cosmology, order at great distance can be unsettling, not because it is threatening, but because it implies hidden authority where our instincts expected only incompleteness. A repeated arc in a cluster field is not calming because it is symmetrical. It is disturbing in the best sense because it means the invisible mass in that region is already organized enough to make ancient light repeat itself. That is such a strange sentence that it deserves to remain strange. Ancient light repeat itself. One background galaxy appearing as several ghosted versions, each one pulled through a different route by the same gravitational field. We're used to repetition as something mechanical, something produced by printing, copying, echo manufacture. Here repetition is produced by curvature. The universe is not duplicating an image because it wants to. It is allowing multiple pathways through a warped geometry. The repeated light is a sign that space-time in that region has become strongly shaped. And shape, once again, is the hidden protagonist of this whole story. Not shape in the superficial sense of how the cluster looks in visible light, but shape in the deeper sense of how mass is distributed, how sharply the potential deepens, how the foreground structure imposes itself on the background field. We keep circling back to that because it is the truth beneath the title. The arcs seduce the eye, but the real revelation is the shape of the hidden mass that made those arcs possible. Webb did not simply deliver an image. It delivered more leverage against the invisible. That leverage matters because in astronomy, The invisible is rarely an optional detail. It is often the main event, gas that cannot be seen directly at certain wavelengths, planets known from their effect on stars, black holes inferred from motion and radiation near their edges, dark matter reconstructed from lensing and dynamics. In all these cases, the universe teaches the same lesson. What dominates a system is not always what dominates the image. Cluster lensing may be one of the clearest expressions of that lesson, because the visible distortion is so dramatic and the hidden cause so fundamental. There is something almost ethical in the discipline that such observations require. You have to resist the urge to love the bright parts too much. You have to accept that the galaxies you can see most easily are not the whole account. You have to trust the evidence of curvature over the seduction of direct appearance. That is not just science as technique, it is science as a way of correcting human bias. We are creatures of surface and brightness. Lensing makes us answer to structure. Once structure takes precedence, the time dimension of the story sharpens further, because hidden structure at great distance is not just hidden structure far away, it is hidden structure from long ago. The cluster core we reconstruct is a core in the past, its concentration, its lensing power, its relationship to the background field. All of that belongs to an earlier universe. We are not only mapping space, we are mapping time through space, and space through time. This is why the phrase deep universe should not be taken too lightly. Deep does not only mean far, it means layered. It means that each image contains stacked realities, one behind another, one before another, one altering another. A cluster lens is not a flat scene. It is more like a cross-section through cosmic history. Foreground mass from one epoch, background galaxies from earlier ones, all braided together by light paths that only make sense once gravity enters the frame. Webb has become a machine for making that layering visible enough to think with. And to think with it is to feel something larger than information. It is to feel the universe becoming less careless in our minds, less like a wash of general grandeur, more like a place with real gradients, real hidden load-bearing forms, real unevenness in the speed and depth of assembly. The old emotional mistake was to imagine the early cosmos as simply less developed, less organized, less capable of producing strong local structure. The more we learn from lensing clusters, the harder that broad simplification becomes to defend. Again, this is not because every distant system is now revealed as mature in a fully modern sense. It is because some of them clearly are not as primitive, in their inner gravitational authority, as the casual imagination wants them to be. That distinction matters enormously. Science almost always advances by destroying the wrong simplification, not by replacing complexity with a slogan. Here the wrong simplification is that distance implies softness. Webb keeps uncovering cases where distance instead reveals structure. That revelation would be impressive enough if it only concerned the cluster itself, but it also reaches outward into the background universe, because strong lensing lets those clusters function as natural telescopes. They magnify and stretch galaxies that lie even farther away, bringing otherwise inaccessible objects within reach, so the cluster becomes a double threshold. It is itself an object of reconstruction, and at the same time it becomes an instrument for looking beyond itself. There is a quiet poetry in that. Though the science is stronger than the poetry, the hidden architecture of one ancient structure helps expose still deeper layers of the cosmos. A gravitational well becomes a lens becomes a bridge becomes a way of reading a past even deeper than the one that formed the bridge itself. The result is that a single cluster field can contain multiple stories of assembly at once: the growth of the cluster, the existence of dark matter scaffolding, the background galaxies whose light is bent, and the telescope that finally catches the whole layered interaction in the present. When you think about it that way, the human role becomes stranger still. We are not simply outside observers, we are the final surface on which these long chains of causation converge. Ancient light, redirected by ancient gravity, ends its journey in our instruments and our pattern recognition. The chain had no intention of reaching us. Yet here we are, late in the sequence, turning it into knowledge. That does not make us central to the universe. It makes us a remarkable consequence of it. And that consequence is fragile. Human lifetimes are vanishingly short compared with the events we are discussing. Civilizations flicker, instruments age. Data archives survive only if cultures choose to preserve them. The cluster lens does not care whether we understand it. For billions of years it existed as a lawful event with no witness. The fact that there is now a witness is contingent, temporary, almost absurdly unlikely. That awareness changes the emotional flavour of the discovery. It adds gratitude without sentimentality. We are lucky in a very exact way. Lucky that the laws of physics are stable enough for ancient light to remain interpretable. Lucky that gravity leaves tracks instead of only swallowing detail. Lucky that minds evolved capable of abstraction. Lucky that a technological civilization persisted long enough to build a telescope like Webb. Lucky that the telescope works. Lucky that the universe contains these structures at all, and that they are willing, in a purely physical sense, to confess themselves through lensing. That last phrase may sound strange, but it captures something real. The cluster does not confess by speaking. It confesses by failing to let the background light pass untouched. It confesses through consequence, through the way mass cannot help but alter the trajectories around it. Every deep structure in the universe reveals itself eventually by what it bends, traps, heats, accelerates, magnifies, or tears apart. Cluster lensing is one of the gentler versions of that rule. The cluster does not destroy the background galaxies, it rearranges their appearance, it leaves a signature instead of a ruin. And a signature is exactly what the story has become by this point. Not a spectacle of isolated facts, but a signature of a universe in which hidden order can emerge earlier than expected, where invisible mass can dominate visible scenes, and where the oldest light can still carry enough coherence for us to reconstruct what intervened. Once that signature becomes visible in the mind, the title pays off in a fuller way. Unexpected symmetry is not only a feature of the image, it is a feature of reality's willingness to preserve pattern across impossible distance. So the question that remains is no longer whether Webb saw something interesting. It clearly did. The deeper question is what kind of universe it has revealed more clearly. A universe where hidden structures were already load-bearing long before we arrived, and where even distortion, if you read it carefully enough, becomes a form of truth. A form of truth, and not a minor one. The kind that changes how you walk away from the subject. Because if distortion can become truth, then a lot of our ordinary instincts about knowledge begin to feel too narrow. We tend to think truth arrives cleanly, in direct view, free of interference. But the universe keeps teaching a harsher and more beautiful lesson. Some truths only appear once the interference is understood. Some structures are only revealed by what they do to everything around them. The deeper the system, the more likely it is to be known by consequence before it is known by sight. That is exactly what a galaxy cluster becomes in these observations. Not just a collection of galaxies in a distant part of space, but a hidden structure with enough gravity, enough concentration, enough internal authority to reveal itself through repeated damage to the background sky. Once that clicks, the image stops looking decorative forever. The arcs are no longer embellishment, they are evidence under pressure, bent testimony, repeated consequences of a deep gravitational fact. And because that fact belongs to the past, the meaning stretches even further. We are not simply learning that such structures can exist, we are learning that they already existed in a form serious enough to lend strongly at epochs where many people's emotional model of the cosmos still expects a softer world. That is the quiet force behind the title. Unexpected symmetry is not really about visual neatness. It is about the persistence of pattern where we thought pattern should have been harder to find. Once you start to feel that persistence, another idea begins to rise from underneath the science. The universe is not only stranger than it looks, it is more organized at depth than surface intuition prepares us for. Depth matters here in every sense. Spatial depth, because the light comes from far behind the lensing cluster. Temporal depth, because we are seeing different layers of the universe at different ages in one field. Structural depth, because the mass that matters most is largely invisible. Even emotional depth, because what first reads as beauty becomes evidence, and what first reads as evidence becomes a revised picture of reality itself. Webb's cluster observations carry force because they move through all of those depths at once. This is why a script like this cannot end where it began. You cannot begin with arcs and end with arcs. You have to begin with appearance and end with consequence. You have to begin with the eye and end with the architecture the eye could never have seen on its own. That architecture is not perfect. It is not a cosmic diagram drawn by some external hand. Clusters remain physical systems with histories, asymmetries, substructure, collisions, gas dynamics, and model uncertainties. They are not solved sculptures, but none of that weakens the central revelation. If anything, it strengthens it. Because even in that complexity, the gravitational field becomes structured enough to leave coherent, repeated signatures. Even in that mess, the lensing geometry holds. Even in an evolving universe, some centers had already become powerful enough to seize light and make the deeper sky curve around them. There is something almost severe about that realization. Gravity is often described gently in popular language, as attraction, as gathering, as the force that brings things together, all true. But in cluster lensing you feel another side of it. Gravity as authority. Gravity as a regime maker. Gravity as the thing that takes a background galaxy minding its own existence and turns it into a stretched, doubled, curved witness to someone else's mass. Not violent in a cinematic sense. More final than that, more lawful, more impossible to argue with. That finality is part of what gives the subject its calm. Strange as it sounds, certainty about consequence can be soothing, not because the universe is tame, but because it is legible. The light bent because the field was there. The repeated image appears because multiple paths were allowed by the geometry. The concentration matters because the core had already deepened. Nothing in that needs sensational language. The evidence carries itself. And once evidence carries itself, meaning begins to settle in a quieter register. We stop asking only whether the early universe was surprising, and start asking what kind of surprise this really is. It is not the surprise of chaos. It is the surprise of premature solidity, of load-bearing structure showing up before our intuition was ready to grant it, of hidden scaffolding exerting itself across the background sky, of a past that turns out not to be vague, but unevenly advanced. That phrase, unevenly advanced, may be one of the most useful to keep. It prevents the usual distortion that comes when viewers hear about striking early structures and begin to imagine the whole cosmos maturing everywhere at once. That is not the lesson. The lesson is subtler and better. The universe develops by difference. Some regions get ahead, some wells deepen faster, some cluster cores become gravitationally persuasive earlier than the mental average would suggest. Webb is helping us feel those differences instead of washing them into one blurry idea of the early universe. And washing things into one blurry idea is exactly what the eye would do without help. That is the beautiful irony in this whole subject. Left alone, the human eye would see almost nothing here. No dark matter, no lens model, no concentration estimate, no cosmic timetable of structure growth. Just a faint and strange arrangement of light. It takes instrumentation, analysis, comparison, and patience to recover the deeper image. In that sense, the discovery is not only about the universe becoming clearer, it is about the human act of clarification, about what it means for a species evolved for nearby survival to become competent at reading ancient geometry. Competent is a humble word, and it belongs here. We are not omniscient. We do not see everything. We do not hold the final answer to the nature of dark matter or the full statistical story of cluster assembly. But competence matters. Competence is what turns wonder into cumulative knowledge. It is what allows a survey to reveal multiple new lensed systems. What allows a distant strong lens to become more than a curiosity. What allows us to say, with increasing confidence, that some cluster cores in the distant universe are more centrally potent than casual expectation ever prepared us to feel. That kind of competence is one of the noblest things science produces. Not certainty without limit, not drama without discipline, just the growing ability to ask better questions of reality and accept better answers when they come. And the answers here really are better than the old ones, better than space is beautiful, better than the universe is big, better than the early cosmos was chaotic. Those statements are not false. Exactly. They are unfinished. Webb's lensing observations make them harder to leave unfinished. Beauty becomes geometry. Size becomes structure. Youth becomes uneven gravitational maturity. The distant background becomes a measuring device. The invisible becomes central. The curved arc becomes a topographic clue to a dark interior. All of those corrections flow together into a final change in perception. The universe is not merely a place where objects exist. It is a place where influence accumulates into readable form. A cluster becomes knowable not by stepping out of hiding, but by shaping the world behind it. That is an astonishingly deep principle, and once you see it here, you start recognizing it everywhere in science. The hidden thing is not silent, it is speaking through consequence. And what Webb has done, in these distant cluster fields, is listen well enough to hear that consequence more clearly than before. So by the time we reach the end of this journey, the title no longer feels like a headline, it feels like a diagnosis. James Webb found unexpected symmetry in distant galaxy clusters because the universe had already built hidden order there, and because ancient light was still coherent enough to reveal it. The symmetry was not decoration. It was evidence that deep structure had arrived, in some places, earlier and more legibly than many of us were ever taught to imagine. That realization lingers because it changes ordinary things: a pane of old glass, a bent reflection, headlights trembling through summer heat, a crack in water around a stone. After this, none of those distortions feel trivial. They feel like reminders that altered paths can still carry truth, that what bends light can be known by the bend, that hidden things are often most visible in their effects. And far above us, in fields of ancient red light, galaxy clusters were doing exactly that long before there was anyone here to notice, shaping the deeper universe into arcs, repetitions, and quiet evidence, until at last a late-arriving species learned how to read the curve and see the structure inside it. What makes that ending so powerful is that it does not really feel like an ending. Once you understand the curve as evidence, the whole sky changes character. Light is no longer just illumination. It is a messenger that has been edited by everything it crossed. Distance is no longer just emptiness. It is a record of interactions. Even the word hidden starts to lose some of its finality, because hidden does not mean unreachable if the hidden thing is strong enough to leave consequences behind. That may be the deepest emotional correction of all. We usually reserve the word hidden for what is effectively lost: a hidden room in a house, a hidden motive in a conversation, a hidden danger in a system. Hidden means inaccessible until something opens. But the universe uses the word differently. Its hidden things often remain hidden in direct appearance while becoming obvious in effect. A cluster's dark matter halo is hidden in that sense. You do not see it like a lamp, or a flame, or a cloud. Yet once the background light bends around it in repeated, constrained, patterned ways, it stops being absent from knowledge. It becomes present through influence. That is a much more mature idea of reality than the one most of us begin with. We begin by trusting surfaces. We end by trusting consequences. We begin by admiring the image. We end by reading the image as an imprint of a larger invisible order. And in that transition, the meaning of Webb's discovery opens all the way. Because what Webb has really done is not simply show us that distant clusters can produce beautiful lensing fields. It has helped show that the deep universe can be structurally articulate much earlier than ordinary intuition expects. It has sharpened the evidence that some of these cluster cores were already powerful enough, already concentrated enough, to bend and multiply background light with a coherence that can be reconstructed into real mass maps. It has taken what many people would have treated as visual wonder and turned it into a more difficult, more satisfying kind of knowledge. Knowledge with consequence. That phrase matters because cosmology can sometimes sound emotionally detached, as though it were only a matter of distant inventory. One more cluster, one more redshift, one more model, one more survey. But none of that is emotionally neutral if you really feel what is being said. To learn that some cluster cores in the distant universe already possessed enough gravitational depth to strongly lens the background sky is to learn that reality was making serious commitments very early. It is to learn that the cosmos was not merely expanding and cooling in some generalized blur. It was differentiating, building contrasts, creating centers of authority, establishing hidden load-bearing forms that would go on shaping everything around them. There is no melodrama needed there. The phrase itself is enough: hidden load-bearing forms. It sounds architectural because architecture is the closest human analogy for a system whose arrangement matters as much as its material. A cathedral is not just stone. A bridge is not just steel. Their power lies in how matter has been organized to bear force and redirect it. In the same way, a cluster core is not just mass. It is mass arranged so that passing light is forced into certain paths and not others. The repeated arcs are the signs of that arrangement. The symmetry is the afterimage of structure doing work. And once you think of it that way, you start to realize how misleading it is to imagine the distant universe as mostly unfinished scenery. What Webb keeps finding, in one domain after another, is that the farther reaches of cosmic history are not just places where things become fainter. They are places where the real tempo of the universe is exposed. We see systems in motion, systems under formation, systems whose internal strength no longer fits the old soft-focus story of youth. The lensing clusters belong to that broader lesson. They tell us that gravity had already been astonishingly effective. Effective is a plain word, but it has weight. It avoids the temptation to dramatize while still honoring what is extraordinary. Gravity did not need to become exotic in order to surprise us. It only needed time, matter, and the lawful amplification of difference. Small initial irregularities became deep wells became halos. Halos fed cluster assembly. Cluster cores became concentrated enough, in some cases, to act as strong lenses. Strong lenses bent the background universe into patterned evidence. Webb captured that evidence, and from that chain, our image of early cosmic structure changed. That chain is beautiful precisely because every link is real. Nothing in it requires decorative language. Nothing in it relies on fake mystery. Nothing in it depends on pretending the science is simpler than it is. And yet the emotional effect is enormous, because once you let all of those links sit together, you can feel how improbable it is that the universe should be this readable. Not readable in the sense of being easy, but readable in the stronger sense of preserving law across scale. The same gravity that makes an apple fall, the same principle that governs orbits and tides, is also shaping the routes of light around cluster cores billions of light years away. The same lawful universe that operates in a room operates across cosmic history. That continuity is one of the quietest and most overwhelming facts we know. It is also what makes the discovery feel intimate instead of merely grand. Intimacy here does not mean closeness in distance. It means continuity in law. The light-reaching Webb obeys the same universe we inhabit. The cluster lensing field is strange, but not alien to the structure of reality that governs our own lives. It is an extreme expression of the same underlying order. That is why the mind can cross the gap. That is why geometry can become a bridge. We are not learning a foreign logic. We are learning how far the familiar logic of gravity can go. Far enough to make one galaxy appear in many places. Far enough to turn the background sky into a map of hidden mass. Far enough to show that some young cluster cores were already deep enough to command the light behind them. Far enough to rewrite not the equations first, but the feeling. And feeling matters. It matters because human beings do not live by data alone. We carry mental pictures, often crude ones, and those pictures govern what new facts seem plausible. For many viewers, the deep past has always felt blurry by default. The distant universe has felt like a place of general infancy. Lensing clusters push against that emotional map. They say, no, the past was already unevenly advanced. No, hidden structure was already strong enough in some places to carve repeating signatures into the sky. No, distance does not necessarily make the universe less intelligible. Sometimes distance is exactly what reveals the shape of hidden order. That last correction may linger longer than any number in the story. Distance reveals, not always, not automatically, but under the right conditions. Yes. The farther light travels, the more history it gathers. The more history it gathers, the more opportunities there are for structure to leave its mark on the journey. Webb is powerful not only because it sees remote things, but because it can capture those marks clearly enough to make them useful. The telescope is, in that sense, less a camera than a reader of consequences. And reading consequences is what the whole human project keeps becoming at its best. We read tree rings and in for seasons long gone. We read ice cores and in for atmospheres no one breathed. We read fossil bones and infer vanished motion. We read seismic waves and infer the deep interior of a planet. And here, we read warped ancient light and infer the hidden gravitational interior of a cluster from a younger universe. Same posture, same patience, same refusal to mistake invisibility for absence. This is why the story lands with such calm force instead of loud amazement. Loud amazement burns out quickly. Calm force stays. Once you see that the arcs are not just decoration, You cannot unsee it. Once you feel that the distant cluster is not just a gathering of galaxies but a concentrated gravitational regime, you cannot go back to the softer image. Once you understand that the hidden structure becomes visible in its effects, reality itself seems less superficial. It seems deeper, more disciplined, and in a strange way more generous. Not because it gives up its secrets cheaply, but because it leaves tracks at all. So by now the title has transformed one last time. Unexpected symmetry is no longer only a scientific surprise. It is a statement about the character of the universe. That pattern can survive distance. That hidden architecture can leave repeated, intelligible marks. That early cosmic time, in some places, was already shaped by structures with enough inner strength to become gravitationally eloquent. Eloquent is the right word here. If we strip it of anything sentimental, an eloquent thing says much with economy. These arcs do exactly that. A few curves of light, a few repeated images, a few background galaxies drawn into impossible shapes, and suddenly the inner mass profile of a distant cluster begins to emerge. Suddenly the timing of structure formation feels different. Suddenly the early universe is no longer a soft prologue, but a place where serious centers had already begun to hold. And the final human meaning of that is not that we are central. It is that we are capable of witness. That may be the most dignified place our species can occupy in stories like this. Not masters of the cosmos, not authors of its laws. Witnesses who arrived late, built carefully, learned slowly, and became just competent enough to recognize that the curve in the light was not noise, but a confession from gravity itself. A confession from gravity itself. That is where all of this was heading from the beginning, even before we had the words for it. Not toward a grand ending in the theatrical sense, but toward a cleaner recognition of what these images really are. They are not decorations from the edge of space. They are not abstract proof that the universe is mysterious. They are confessions in the strictest possible way, consequences that cannot help but reveal the structure behind them. Gravity does not speak, it leaves curves. And those curves, once Webb made them clearer, turned out to say something stronger than many people expected. They say that some distant galaxy clusters were already carrying serious inner structure, serious enough to bend the background sky into repeated forms, serious enough to make the invisible legible, serious enough to force a correction in how we imagine the young universe. That correction may be the most valuable thing this whole story offers, because what changes us is not usually one new fact. It is the collapse of an old mental picture. The old picture here was simple. Far away means blurred. Early means unfinished. Hidden means less real than what shines. By the time we reach the end of this journey, all three of those intuitions have given way. Far away can become more revealing, not less, when distance lets us witness ancient interactions. Early can contain formidable structure, at least in some places, long before our instincts are ready to grant it. Hidden can dominate the entire scene, shaping everything visible without appearing directly at all. Those are not minor adjustments. They change the emotional architecture of the cosmos. After that, a galaxy cluster can no longer be just a swarm of distant lights. It becomes a gravitational regime, a region where matter has gathered into enough authority to alter the route of ancient light, a region whose invisible mass can be reconstructed from the injuries it inflicts on the deeper sky, a region that existed long before us, acted long before us, and still leaves evidence precise enough for us to read. That last part is what lingers most for me. Not only that the cluster was there, not only that the lensing happened, but that the evidence survived, across expansion, across time, across unimaginable distance. The pattern held together well enough for consciousness to catch up with it. That is extraordinary in a way that does not need to be embellished. Ancient light crossed the universe, passed through a hidden gravitational architecture, and arrived carrying the marks of that passage like a sealed record. We opened it late, but we opened it. And in opening it, we learned something unsettling and beautiful. The deep past was not a featureless waiting room for the present. It was already sorting itself into strong places and weak places, into deep wells and shallower ones, into regions where gravity had already done enough work to leave clear, repeating signatures in the sky. The universe was becoming structured with a seriousness that our ordinary language about the early cosmos often fails to capture. That seriousness matters because it restores consequence to deep time, It reminds us that cosmic history is not only a procession of ages, but a progression of authority. Some structures emerge, deepen, and begin to govern what happens around them. In a cluster core, that governance becomes visible through lensing. Background galaxies do not pass untouched. Their light is edited, stretched, multiplied, and redirected. The cluster declares itself by changing the world behind it. There is something profoundly satisfying in that idea. Hidden things are not silent forever. If they are strong enough, they write themselves into their surroundings. A black hole writes itself into the motion of nearby stars. A planet writes itself into the wobble of a sun. A buried fault writes itself into seismic waves. A distant cluster writes itself into warped ancient light. Reality is full of these indirect revelations. The invisible does not stay unknowable. It becomes legible through influence. And influence is the right final word for these clusters. Not beauty, though they are beautiful. Not mystery, though they remain mysterious in many ways. Influence, the power to alter trajectories, the power to make background light repeat itself, the power to reveal hidden mass through structured distortion, the power, even in the young universe, to become load-bearing. Once you feel that, the title opens one final time. Unexpected symmetry was never really about neatness. It was about the moment when distortion stops looking random and starts looking lawful, when repeated arcs stop looking ornamental and start looking inevitable, when the image stops being something strange in deep space and becomes an argument made by light on behalf of invisible structure. And then something even quieter happens. The discovery reaches back into ordinary life, a warped reflection in a window, the doubled headlights seen through heat over a road at night, the bent outline of a spoon in water, the way a body can be understood by the pressure it leaves in a mattress, a footprint, a chair, a floorboard. None of those things are the same as cluster lensing, of course, but after this, they feel related. They remind us that the world often tells the truth indirectly, that altered paths can be evidence, that distortion is not always the enemy of understanding. Sometimes it is the form understanding takes. That may be why this subject feels so human, in the end. Not because galaxy clusters care about us. They do not. Not because the universe was waiting to be discovered. It was not. But because we are the kind of beings for whom bent light can become meaning. We can sit on one small planet, inside one short civilization, under one quiet sky, and learn to read the hidden interior of a structure billions of light years away. We can notice that one faint arc belongs to another. We can infer a deep well from a repeated image. We can recognize that the past was already more organized than our instincts believed. Small creatures, late arrivals, still capable of witness. That is enough, more than enough, really. Because witness, at its best, is not passive. It is disciplined attention paid to what is actually there, and what is actually there, in these Webb observations, is a universe that did not become less real with distance. It became more exacting, more layered, more structurally articulate. The farther we looked, the more the old simplifications failed. Not because the universe dissolved into chaos, but because it turned out to contain hidden order earlier, and in some places more decisively than we had emotionally prepared for. So when we look back one last time at those distant clusters, what remains is not just a scientific result, it is a changed perception. We no longer see decorative arcs, we see a map written in injury, we see ancient light carrying the shape of a gravitational encounter, we see hidden mass made visible by consequence, we see early cosmic structure not as a vague prelude, but as a landscape where some centers had already grown deep enough to command the sky behind them. And maybe that is the line that stays after everything else fades. The universe did not wait to become structured until we were ready to imagine it. It was already building wells in the dark, already bending distant light into repetition, already leaving behind the evidence. And somehow, against all odds, we arrived late enough to miss the event and early enough to read the curve.